Today we're gonna do this is part one of my ATX power do-it-yourself ATX power supply tester. It's gonna have some very interesting stuff we can do to make a pretty good one. We're gonna have it loaded on all the voltages except for negative 5 volts. I decided to leave that one out because it's obsolete. It's for using older computers that have ISA slots. Anyway, the whole idea is you have to have a load for the 5 volt one, and that's important. You have to have a load at least for that one. You can find a ATX power supply schematic on the internet, but it's so simple, but it probably won't be 100% accurate or very accurate as like this will be. This will be more accurate because it's going to have some more. It's going to have some more testing stuff in it, like we're going to use voltage dividers to divide the voltage out so it can, so the LED will light only at a certain voltage, and also at a certain the signal's not too weak also as well. If the signal's too weak, it'll also divide out too much and it won't light the LED, which is a good thing. Anyway, let's get started. Okay, here's our specs. We got here. This will be very easy and simple, straightforward specs. Now, right here, the 4.7 ohm load on 5 volt and 3.3 volt. In fact, you don't need a resistor there. You can just use an LM317 with a resistor on it, and the current doesn't have to be very, very strong. I figured that out because I had a tester of my own, and I measured the current, and it wasn't that strong as I thought it would be, and so you can use the LM317. It's safe. It's the current range is safe enough to be in the range you can use the LM317 as a current regulator. And that's what I'm going to use for the 12 volt one, since it's going to be expensive trying to buy a 12 volt. Well, it probably wouldn't be, but the thing is, I didn't want to go out and buy a component for it. I just wanted to use what I had. I had a whole bunch of LM317s on there, and I had a whole bunch of small, tiny quarter watt resistors I could just use, and quarter watt of that would give me enough current to test it. Anyway, let's move on to the next one. No digital computer bullshit. Now, what I mean by that is that we're not going to use those. We're not going to use analog to digital converter. We're not going to use a microcontroller or a PIC or any of those devices or Arduino. We're going to use simple and straightforward analog circuitry to turn the LED on when it's on there by using this down here, a voltage divider. If you don't know what voltage divider is, this will help you learn it. There's 2 resistors here, and each one of them make up a fraction of how much you can divide the voltage from the top one, between the top one and bottom one, and in the middle is the output. And if you have 2 resistors that are the same, it will divide them in half. In fact, for the 5 volt well, we're going to divide it in half, so you get 2.5 volts, which should be pretty low. Should be the lowest enough to be perfect good for LEDs, since LEDs can't light up very lower than that. Anyway, another thing we're going to do is we're going to right here it says use voltage dividers to check the voltage in LEDs. We just talked about that. Anyway, we're going to use a power switch, a toggle switch to switch the thing on and off. The voltage regulator is going to go for testing 12 volts. It's also going to test the negative 12 volts. I decided since the current is so low on it, that we can just use one voltage regulator between the positive 12 and negative 12. It'll be 24 volts. If the thing is that voltage regulator, 24 volts will not harm it. because it's still in safe range. What you'll want to need to get for a connector is you want to get an extension cord. Now, these extension cords may have wire coloring that's not the same on it. As you can probably see here, I'll show you. For example, I got one of the connectors that I cut off the broken power supply here. As you can see, that the yellow wire from this here, which is a positive 12, goes to a black wire. Now, if we tied all those to ground and I didn't check that, I would have short circuited the power supply, and the power supply went turn off real fast. And bad stuff could happen. Could melt wires, a whole bunch of stuff could happen. Break our voltage regulator, anything like that. So it's a good thing to have an in like that, or just use in on your power supply to test it. Because those went off eBay, they didn't do it by the ATX color code, like the original ATX color code. In fact, the green wire is purple, as you see on the switch here. The white wire is another ground, so I put that for a ground on there. This here is our voltage regulator. That's acting like a current regulator. It has two resistors on it. It's because I wanted to make 6.6 ohms, so it's something close to 6.25. And the only thing I get close to is 6.6. So I took a 5.6 ohm resistor and a 1 ohm resistor, put them in series inside together, to make a 6.6 ohm resistor. It does heat up on it, so you gotta be careful with that thing. In fact, you probably don't want it very too long. You probably just test it on it to see if it turns on stuff. It's good enough. It doesn't heat up that much anyway, because it's not drawing like an amp like a car charger would. It's drawing way less. So what voltage should we use? What resistor should we use for our voltage divider, you might ask? We're gonna use for the 5 volts. We're gonna use two. I think I chose 150 ohm resistors. Then for the 12 volt, we're gonna use 1.5 kilo ohms for the R1. R2 will be. This is R1. The top one is R1, and the bottom was R2. And R2 will be 470 ohms. And that will make it where it has to be at least 12 volts or so before it'll. I don't know how much it divides it by, but I tested it out and it turns off when other voltages happen on it. Now, and besides, if the testers like that since it's a Dell one, we think it's made professionally made. They didn't shut off at certain voltages where it went low enough. They didn't use voltage divider. The thing is, this voltage divider will be better than it. If there was a load on there, it will help. Because that's how they do it. They put a load on it, and the load weakens the strength down if it's too weak to one. Anyway, and also this resistors here, the 4.7 ohm resistors, these big white things, they heat up too. And, they do heat up, but not enough to break it, or just make a little heat. They do make it heat enough that we can't touch it, hardly touch it at a certain time. They're 10 watts, so I don't think they'll break, because I calculated if Ohm's law, calculated out that the 5 watts on it, on both of them. 5 watts on The 5-volt one, probably 6 watts at the most. And then 5 watts on 3.3 volts. Anyway, enough about that. Let's do some examples with our resistors to show you how they work. Okay, now we got it hooked up to a 12 volt voltage divider. As you can see, it's on 12 volt. Well, and the LED is lit up. Now let's go to 5 volts, shall we? Connect this to the 5 volt. This one to here. Why is the light's blinking like that? Because this was just loosen it. Doesn't divide. Well, it's working like it should. 5 volts on that one. Gives us nothing. If you go all the way over to 3.3 volt. Nothing either. That shows that idea will work. We can use voltage dividers to measure the voltages. You don't need no computerized chips or anything in it to like measure the voltage. We can just use voltage dividers and an LED for each one. But the thing is, for 3.3 volt one, just use regular current limited resistor wire with one resistor and an LED. So now let's see what the tester gives us for it. See what our expected currents from our other our tester that's made by Dell, and see how it measures out to be. Okay, let's measure the current from the 12 volt on this cell tester. See what it gives us. A 12 volts going to cost it. So far we got 250 milliamps. 250 milliamps, yeah, from 12 volt. And that's close to what I put my regulator at. So I bet my regulator will do well for it. Now I'm going to try 5 volts. Once I get the 5 volts wired up. $310 milliamps for the 5 volt one. And when it's doing that, power good lights up too. And that's okay if we draw over that, a little over that on our loads. That makes it a little bit even better, because what Dell did, they want to use a cheap way to do it, and they just did it with the lowest current that they think that it was a source. So they chose that kind of resistor. Okay. Now we're gonna do the 3.3 volt one. I tested it earlier, and it beeped that there was a buzzer inside it and went off when I did the 3.3 volt one. It's probably because it's only doing it because it only detects that there's only one voltage on it, the 3.3 volt rail. But I don't understand if that could be it or not. I don't know. For some reason, when it's just that, probably just that much, when that 1 voltage is on there, it turns the buzzer on. You'll hear it when I turn it on. As you can hear, it's on there, but the thing is showing 492 milliamps. And that's how it tells you that that the load doesn't have to be that big, because they'll not use very big loads in the power supply tester. In fact, you're gonna probably replace every single thing in there, every single load you put on there, with a current regulator, or the LM317. And regulate at some currents. In fact, then you don't have to have very big power resistors, then, because when the current regulator, when it regulates it, the current is going, when it goes to that one resistor, the reference resistor, it's going through it. So what voltage is going to? It's 1.25 volts, which is hardly anything, and which will make it where the current ain't gonna be that high as it was the wattage would be that high as it would with one that drew without do it with the regular resistor, or with just one resistor instead of resistor and voltage regulator, using it as a current regulator. Well, that's it for now. Stay tuned for part 2 and part 3 of this video. I don't know if this will be a part 3, but it might be part 2. Yeah, there'll be a part 2 to it. Once I get the power supply, my power supply went dead. Then his friend shared the power supply test with me and found out that it's actually the power supply that went bad. I opened it up and found some capacitors leaks in it. Bulged up and leaked on the top of the like brown spots on the top of the tips of the capacitors where the vents opened up. Well, that's it for now. So I hope you enjoyed this video. Thanks for watching. Hope you like it.